Let's look at calculating formal charge. To calculate the formal charge of an atom when it's in a polyatomic ion is pretty simple. And clearly, if we're talking about calculating a charge, it must be in a molecule that is an ion because that's the only molecule that will carry a charge. Now, I taught you how to do Lewis dot structure for neutron molecules. Follow that rule for neutron molecules only. If you need to do the Lewis dot structure for a polyatomic ion, and polyatomic just mean a molecule that has more than one atom in it with a charge on it, right? So if you need to do the Lewis dot structure for a polyatomic ion, follow these rules. Before you can calculate formal charge, we're going to have to draw the Lewis dot structure of the ion. So let's look at the rules to follow to draw the Lewis dot structure for your ion. One, first thing you need to do is calculate the total number of valence electrons in the ion. That's one. Two, for each positive charge minus one, right? That's for each positive charge on the ion. For each negative charge, add one. So for example, if your ion, your polyatomic ion has plus two, it means you minus two. Then determine where to draw your single bonds. And once you've drawn your single bonds, right, you need to double check to make sure that you have a full octet, right? That the octet for each ion is complete. If not, you might have to draw double or triple bonds if necessary. We're going to do some examples and I'll make sure to cover examples where you have to do a double bond. Now, a question will ask, to calculate the formal charge in an ion, and it will ask you to calculate the formal charge on a specific atom, right? So we're going to calculate the formal charge on oxygen in H3O plus. And I'll explain why I knew the charge was on oxygen and not on hydrogen. I think this one is obvious, but I'll give you a template so you can know when an atom is neutral and when they have a charge. We'll get there. But let's look at how to calculate the formal charge on H3O plus. First things first, let's follow the rules. We're going to calculate the number of valence electrons in H3O plus. I have three hydrogens, one electron each. So that's 1 times 3 equal to the 3 electrons. Oxygen, and I'll remind you how to get the number of valence electrons. Go to your periodic table. Oxygen is over here in group 6, so oxygen has 6 valence electrons. And then I'm going to add the 3 and the 6. I get 9 electrons, right? But remember, for each positive charge, you must subtract 1. Don't forget that this plus here means plus 1. So we have 8 valence electrons in H3O plus, which means that when we draw our H3O plus connecting the atoms with single bonds, we need to have a total of 8 valence electrons. So I've placed my 3 hydrogens bonded to the oxygen, right? Let's count and see how many valence electrons I've taken care of. 2, 4, 6, not 8, right? And we have 8. So it means this oxygen has a lone pair. Clearly, you can't put the lone pair on the hydrogens, right? That would make absolutely no sense because the hydrogen already has its full octet, right? The only thing that didn't was the oxygen, okay? So you have to do some reasoning when you do this. Let us now go to how we calculate the formal charge. There's a formula for formal charge. So the formal charge is equal to the number of valence electrons. I'm going to use VE to represent valence electrons. This number of valence electrons in the non-bonded atom, and that's like when the atom is in the periodic table, not bonded to anything, right? Minus all unshared electrons, and this is clearly for the atom in question, right? So in our case, it's oxygen. Half times the number of shared electrons. Don't forget that unshared is also the same thing as non-bonded electrons, right? And shared is the same as bonded. electrons. So let us calculate the formal charge for oxygen, right? So to calculate the formal charge for oxygen, Fc is equal to the number of valence electrons for oxygen when it's in the periodic table group, it's in group 6. We should know that by now, right? So that's 6 electrons, right, minus all unshared electrons on the oxygen. Remember, this formal charge equation is for the atom in question. So find the oxygen and let's see how many unshared electrons we have, right? It's 1, 2. So this is 2, right? Plus a half the number of shared electrons. How many shared electrons do we have? And shared are bonded electrons. When you say shared electrons, you're talking about electrons that are shared between two atoms. So these are the shared electrons that are on oxygen. 2, 4, 6. So a half of 6 is 3. So 6 electrons minus 2 plus 3. I need one minus here. Let's take one of these out. Get my eraser. Here you go. All right. 6 electrons minus 5 electrons is equal to plus 1, which is the formal charge on your oxygen, which is why your formula is H3O plus. This plus is on the oxygen. I'll explain to you in a second. You can go ahead for your own practice and calculate the formal charge on the hydrogen. You're going to get 0. I knew the formal charge on the oxygen. It couldn't be on the hydrogen. Hydrogen is neutral when it has one bond attached to it. I'll talk to you about when you can know if an oxygen is neutral in a second. But let's do another, let's go ahead and do another example. So let's erase some of this and make ourselves some space so we can work another example. Let's try to do H3 HCO3 minus. Let's try that one. Alrighty. So HCO3 minus, right? We need to calculate the formal charge, and that formal charge is going to be on one of those oxygens. So we're going to calculate it on the oxygen. But first, we must draw the Lewis dot structure. So let's follow the rule. Total number of valence electrons in the ion. So we're calculating the total number of valence electrons in HCO3. One hydrogen, so that's one electron. Carbon is over here in group 4, so that's 4 electrons. Oxygen is in 6, but I have 3 of them. So it's 6 times 3, that's 18. So 18 plus 1, 19, plus 4, 23 electrons, but I have a minus charge. For each minus charge, you must add 1 electron. So we have a total of 24 electrons that I need to distribute when I draw the Lewis dot structure of H3O plus. Let's connect our atoms with single bonds. So let's drop a carbon here. Let's put in our oxygen. We have 3 oxygens, and I have put the 3 of them in. I have a hydrogen left, right? And this is me playing around here to, just connecting single bonds. Let's see if I have the right Lewis dot structure. Let's give everyone a full octet. I already know that the hydrogen has a full octet. So does the carbon, because I have 2, 4, 6, 8. It's the oxygen that doesn't have a full octet. The oxygen only has 2 electrons, so I needed to give it 6 more. That's why I'm drawing these lone pairs. And you have to draw lone pairs. I don't have any other atoms to bond to it, right? But let's see if we did the right Lewis structure. 24 electrons, remember? So let's count. We have 2, 4, 6, 8, right? 10, 12. Let me use this laser. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That is too many electrons, which tells me that we do not have the right Lewis dot structure. So we need to try again. First and foremost, it's obvious that the only thing I could do with this hydrogen, since it doesn't fit on carbon, I am going to have to put it on one of these oxygen. I'm just moving that oxygen from down there and putting it up here. It's just for aesthetics. I prefer it up here based on what I'm about to draw. So the hydrogen is clearly on one of these oxygen. So let's put it on one of these oxygens, right? Now, let's see if everybody has a full octet, and then let's see if we have 24 electrons. So oxygen 2,4, laser. 2,4,6,8. Oxygen happy, hydrogen is good, but okay. 2,4,6. Carbon isn't okay. Your oxygen here, they are okay, but carbon isn't, which tells me, remember, you don't have any more atoms left. We've taken care of the 3 oxygen, the 1 carbon, and the hydrogen. So that tells me that one of these oxygen need to form a double bond with carbon. There's nothing else you could do. You literally, only other option is to take the lone pair here and make a double bond right here. Something we didn't do. Let's do something here. Let me put this back and let's see if we have 24 electrons, right? Mark you, this cannot be the lowest structure on the grounds that the carbon is not happy. It doesn't have a full octet. But let's just see, do we have 24? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 20. So you have 24. Beautiful, right? That's great. But carbon does not have 4 bonds. So right at this point, what this tells me is that I don't have any more electrons to put onto this atom. No, because we have 24. So it means the only possibility for me is to make a double bond with use these 2 electrons, transfer them in here and make a double bond. That's the only way because I only have 24 electrons, right? And in order to keep the number at 24 is to convert this into a double bond. No, this is your full, everybody has a full octet now, right? Um, this has a full octet. This oxygen 2,4,6,8. Carbon is chilling. It's 8, 2,4,6,8. Oxygen 2,4,6,8. So everybody has a full octet. So it means our lowest structure is good to go. Okay. Now I know that the charge is on this oxygen, and right after I calculate this one, I'm going to show you how I knew that. So let's calculate the charge on the oxygen with the arrow because we have this oxygen and we have this one. There's no formal charge on these. Formal charge here is 0. Soon talk to you about how I already knew that. So let's calculate the charge on this one with the arrow. So Fc is equal to number of valence electron in the atom in question. Number of valence electrons in oxygen is 6 electrons, right? Minus the number of unshared electrons on that unshared electrons on that oxygen. Let's look at the number of unshared electrons on this oxygen. It's 1, 2, 3, 4, 5, 6. So this is going to be 6 electrons plus a half the number of bonded electrons on this oxygen. This oxygen only has 2 bonded electrons to it. Notice my focus is only on what's going on with this oxygen, okay? So the number of bonded electrons here is 2, okay? So let's put our 2 here, 2 times 2. 2 into itself 1, 2 into 2, 1. So 6 electrons minus 6 plus 1 is 7 electrons minus 1. That's where your minus 1 charge come from. It's on this oxygen. Let me tell you how I knew this oxygen has had the formal charge. This is something every chemist should know. Anybody in general chemistry, organic, you need to know when hydrogen is neutral, what it looks like. When oxygen is neutral, what it looks like. When nitrogen is neutral, carbon, and any one of the halogen. So let me show you. A hydrogen is neutral when it has only one bond to it. And you will see a hydrogen only with one bond, right? But for your other group 2 elements, oxygen, you can see it, for example, and that it was the first example we did. You can see an oxygen and it can have a charge on it, and it isn't. That means it's not neutral. But let me show you what a neutral oxygen looks like. So this is a neutral oxygen. An oxygen that has two single bonds and two lone pair is neutral. You see anything else in this life, anytime you see an oxygen with any other combination, it has a charge, right? Also to point out, if I have C double bond O, this is also two single bonds on the oxygen and two lone pair. This oxygen has no charge. But remember when we did H3O plus, right? You see, this oxygen don't look anything like this. It doesn't have two single bonds and two lone pairs. It has three single bonds, right? And so therefore, it has a charge and it has a positive charge. Now you can calculate this charge. You could also reason it. When we get into writing reaction mechanism, I'll teach you how to reason out the charge. So next thing I need you to remember is when nitrogen is neutral. So nitrogen is neutral when it has three single bonds and a lone pair. You see anything else, that nitrogen has a charge. So for example, if you see this nitrogen has a charge. Any nitrogen without three single bonds and a lone pair has a charge. Carbon. Carbon has no charge when it has four single bonds. Anything else, carbon will have a charge. So when you get more into organic and you start talking about carbocations, that is a carbon with three single bonds. So if you remember this, it will make your life so much easier in chemistry when you start writing reactions, just to know which atom will have the formal charge. You also need to know this for your halogen. Any halogen, right? Once it has a single bond and 1, 2, 3, 4, 5, 6 lone pairs, it is neutral. You need to remember when these things are neutral. I'll teach you how to reason charges when we start writing reaction mechanism. But for right now, please remember when a hydrogen is neutral, when an oxygen is neutral, when a nitrogen is neutral, how many bonds are literally just what it looks like. Three bonds, lone and a lone pair, right? You gotta know when carbon is neutral. Same thing for chlorine. So this is formal charge. Pretty simple. Just follow the rules. Take your time. Practice. The more you practice, the better you'll become at this. And use this so you could know which atom has the formal charge. You don't sit there calculating all of them when you're given a question.